So what is orbital velocity of a satellite? On satellites, I will arrange a separate video part, but today I will talk about only orbital velocity. The orbital velocity, actually, it is a constant velocity with which a body revolves around another body, basically. But here, because we are talking about the Earth, the particular planet, and the body that revolves around the Earth is basically called satellite. Orbital velocity is a constant velocity with which a body that is basically, in our case, is satellite. A satellite revolves around the other body, and here other body is basically Earth. But it can be any other planet, because every planet has so many natural satellites. So a satellite is the body that revolves around the planet. So for example, the moon is a natural satellite of the Earth, but the body that we make to revolve around the Earth is called artificial satellite. So a constant velocity with which a satellite revolves around the Earth in a circular path basically is called orbital velocity. So whenever we launch any satellite from the Earth, so it needs a escape velocity just to escape from the gravitational field, but as soon as it enters the orbit, it gains some velocity with which it starts revolving around the planet or Earth. So this velocity is called orbital velocity. Consider this is the Earth and this is the satellite, and this satellite wants to move around the Earth with a constant velocity. So how it will move, which force it requires to move in a circular path? So the force it needs to move is centripetal force. Now question is, how this satellite will get centripetal force? So the answer is basically comes from the Newton's gravitational law. What is Newton's gravitational law? Newton's law of gravitation says there always force exists between two masses. That force is basically g m1 m2 over r square. Gravitational force is inwards, and what it needs to move in a circular path? Centripetal force. So now which force is providing centripetal force? Earth's gravitational force, Earth's gravity. The gravity source is in the center of the Earth. Due to the Earth's gravity, this satellite will start moving around the Earth. So we'll say that Fg, gravitational force of the Earth, will provide the centripetal force to the satellite to move in a circular path. So that's why these two forces are kept equal here. What is Fg? G m over r square. And what is Fc? It is mv square over r. Alright, so here m will be cancelled and r will be cancelled. So it will be gme over r naught is equal to v square, taking the root both sides. So what happens? V is equal to root gme over r naught. This is gm over where r naught is basically, this is the Earth and this is the satellite. So this is the Earth center, like this. This distance is the radius of the Earth and this is the height. The total distance is r naught. So r naught is the sum of r plus capital R plus h. This height is not fixed because your satellite can be anywhere. It can be near to the Earth and it can be far away from the Earth. If the satellite is 900 kilometers away from Earth, it is moving around the Earth at 900 kilometers. So what will be its orbital speed? We need to find out the orbital speed. So we'll apply the same formula. V orbital is under root gm or r naught, that is gm r plus h, that is under root, what is g, 6.67 into 10 to the power minus 11. What is the mass of the earth? This is mass of the earth 6 into 10 to the power 24 kilograms divided by r plus h. What is r? Radius of the earth. Radius of the earth is 6400 kilometers plus what is the height? Height is 900 kilometers. Height given is 900 kilometers. So we will get 7.4 kilometer per second. This will be our orbital speed. 7.4 kilometer per second. This is the orbital velocity of the satellite that moves around 900 kilometers from the earth. Suppose the earth is here. This is the center of the earth. This is the radius, and the satellite is here. That is 900 kilometers, and it is revolving like this at constant radius, at constant speed. The satellite has a constant speed here, it has a constant radius, and the speed with which it is basically revolving around the earth is called orbital velocity. And in this case, if it is 900 kilometers away, the orbital velocity will be 7.4 kilometer per second. It would be around 7,400 meters per second. If force is here, the acceleration will also be here, because when we apply the force on some body, the body moves ahead and acceleration is produced in the same direction of force. So acceleration and force have the same direction. So when a body moves in a circular path, so first we need to find which force is providing the centripetal force. So in this case, gravitational force is providing the centripetal force. Where is the direction of gravitational force? Here, inwards. So and acceleration and force have the same direction. This is what we have learned here in Newton's second law. So gravitational force will be inwards and centripetal force will be inwards. Radius and velocity are inversely proportional to each other. So that means that if we increase the radius, if this satellite travels far away from the earth, so its speed will reduce. As we increase the radius, the velocity will decrease. If we increase this will decrease, because these two quantities are inversely proportional to each other. So what happens? As the satellites move away from the earth, its speed will decrease. As the satellite moves near to the earth, its speed increases. It will move with a greater speed.